meeting, but I want not to delay it. We are like 5-6 minutes already. I'm ready to welcome Jonathan, he and maybe alone or with some colleagues, they contributed 2 modules in the last year, in the last release. They came also to Düsseldorf at the Devel meeting, so they are quite active, let's say, in the community, at least the last year. Thank you for coming. Looking forward to your presentation, Jonathan. The floor is yours.
Thank you, Daniel, and thank you for having me. It's a really nice and contentful conference. Today I will walk you through how we rethink notification using Kamailio with Arnacon in the ecosystem. The goal of today's presentation is to show you how we can remove complexity and prior trust assumptions and long and hard integration time required to set up a system like this. My name is Jonathan Kandel, and I work in Cellact. Cellact is an MVNO in Israel, providing secondary numbers inside an app for experience without supporting physical SIMs in the last years. We moved everything to be virtual. We've been using Kamailio for many years, and in order to integrate telephony systems. Over the time, we experienced complexity and a lot of hard integration and operational challenges on the way. So we took all of these problems and we wanted to bridge and build a solution that will help us to remove any hard and struggles. And by the name of Arnacon, this startup started in the Netherlands 4 years ago. And since then, we are building Arnacon, and more about it later. Elena yesterday explained a little bit about what is a notification in SIP. I will also briefly talk about it. It's a telecom notification is not just push messages. They include SIP signaling and variable information that the phone needs in order to register when it's offline. So for example, a user is coming and wants to send a message to someone, and that device is offline. We are sending him a push notification to wake him up and let him know there's something that he needs to do. There are 2 types of notification systems. One is APNS for iOS devices, and the other one is FCM for Android. Until now, in the traditional way, we've done notification as following. A user initiates an invite, then the Kamailio gets the invite, and he authenticating the user with a local pre-established trust database, if it's a Redis or if it's a MySQL in the past, and with an RFC 2617 that we all know. And once this authentication is completed, the Kamailio gets the state. Then he uses already stored credentials that the Kamailio have, and is making a request to a trusted API, letting know the API that we want to send a notification to the other recipient to wake him up. The trusted API gets the request, is validating the credentials or wherever it is, and then the trusted API sends the notification to the relevant notification channel to broadcast it directly to the recipient user, and returning then a response that will later be used to the user. Then Kamailio depends on a local database and provides a local and trusted API that needs to be pre-configured and pre-established trust between them. Each integration is manual and required and repeated. In Arnacon, we're doing this by a user is sending an invite, again, sending to the Kamailio server, a cryptographic signature that can be validated with the user identity and fetched dynamically from a decentralized cloud. We contributed a model that is off Web3 that allows to validate and authenticate the user as the following. As you can see, it's really similar to how the normal off model is being run. The difference between them is the off Web3 model is not being validated against a local database, but rather fetched dynamically into a decentralized cloud. After a successful verification is being done, we can move to the notification. Kamailio is making a request to Oasis Sapphire in order to request some notification details. This is where we are making some big changes, where the Oasis Sapphire, it's a decentralized cloud functions that allows different service providers to upload their secrets. For example, their APNS, FCM, private tokens, and securely into a trusted execution environment. This allows this decentralized cloud to run code for us without revealing the secrets that we pre-uploaded. So every service provider can come, upload their secrets, and then the Kamailio can make a request to the signaling plan with this, all the relevant details and the notification type that we wanted, and then returning back the steps required for that plan to be executed. And this decentralized cloud to generate a JWT that can be later exchanged to an access token can look something like that. If you can see on the right side up, there is a get APNS key that is the specific service provider pre-uploaded key that can be used to sign the request that can be later be broadcast to the correspondent notification channel. In this case, this is an example of an APNS. After we get the request authorized and delivered back to the Kamailio, it's without still broadcasting it to the corresponding notification channel. We can send the notification from the Kamailio directly to the notification channel after we make some small operations on the Kamailio side, like exchanging the JWT to an access token with Apple or with Firebase, and then sending the notification to the corresponding notification channel. Then we get the response and we are returning it back to the user. So why does it matter? Because there's no more local database that is coupled with the Kamailio instance. We removed the integration cost because we don't need to maintain a remote API. It's much more secure because we don't need anymore to maintain or have a one-point failure system because it's decentralized. And it's easy onboarding for new service providers to come and upload their own secrets, and then everything that is pre-established and configured can be used forward. Now a user that is registered this way can receive Kamailio trigger notification from another service without that service owning the user's authentication record before. We removed integration heavy to a plug-and-play components, where telecom can be just as easy as a trustless authentication. The notification channel and the authentication are decoupled components that are no longer needs and relying on one another. So the Kamailio becomes the place where telecom apps can run. What we just saw, it's not just a feature, it's a platform we can all build on, where we separate authentication, notification, and the communication from one another. Anacon brings trust into a trustless environment, where we don't need to establish trust between parties before communicating with one another, where the user identity can be cryptographically verified and can be as simple as a cryptographic wallet. Service can communicate easily without deep integration. So the Kamailio state becomes making it stateless. So it's easy to have a load balancer making up and down without needing to connect it into a specific database or an API. Let me do a small recap what actually changed from the traditional way into the new way. In the traditional way, we had a local database that we needed to validate the user's authentication, where in the new way, we validate dynamically with cryptographically way. In the traditional way, we had to store credentials and validate them on the remote API, where in the new way, we are retrieving them dynamically with this decentralized confidential cloud, and the Kamailio itself broadcasts the notification to the notification channel. So in the traditional way, we had tight coupling between all of these systems, and in the new way, there's no more coupling, so the integration becomes super easy to onboard new service provider or new integrators that want to enable services. I like to show you how like a full structure of the ecosystem looks like it. On the bottom, we see that this is the Arnacon protocol that acts as the foundation layer where identity, trust, and verification lives, where coordination between parties is handled. This is the foundation that everything relates on. On top of it, we have the communication layer. This is being charged by Kamailio. Kamailio handles the SIP signaling, the routing, and connects service providers, carriers, and operators. It manages the service provider settings, and it's interconnect between networks. I like to think about it as the traffic control of notification flows, of communication flows, sorry. But something is missing. All of this infrastructure, but how users and service providers can actually use it. This is why we built the Arnacon app. It's a runtime telecom service. It's the experience layer where services become usable. This is where the UI lives. It's a client without maintaining a SIP client. It enables provider to launch their own application with their own look and feel without their need to maintain and operate it. Arnacon protocol provides the trust, where Kamailio provides the communication, and the Arnacon app turns all of this into a usable, experienced services. I will focus a little bit about the Arnacon app, where we realized at this point that we're not building an app. We're enabling many services to be run on that app. Then the Arnacon apps become a phone where telecom apps can run on and installed. Then if the Arnacon app become a phone, then we need a place to download applications from. And the best way to describe it is like an app store. It's, we call it the app store model, where services can be installed into that phone, into this app. As well, if you have already your own app, then there's an SDK that can be supported as well. And the Arnacon app, it's the runtime environment for these telecom apps. Once you install Arnacon, it instantly supports future applications, like a phone supports new apps when they're being uploaded to the App Store. There's no more hard integration cycles, and there's no more backend app wiring required when new app come along. Everything is a plug and play to the authentication, communication, notification layer that I presented before. I like to think about it that if Twilio enables API communication in the backend, then Arnacon enables them in the front end. These are just some of the examples that we see that Arnacon can be used for. The secondary number is an application that Cellact in Israel is selling virtual numbers to customers, where the initial time estimated to build a new app from scratch right now would have been around 10 months. We recreated this app inside Arnacon, and we managed to reduce integration time to less than a week of creation of this secondary num. And an installation will look something like this. Doesn't want to. Here we are in the service provider store. For that, it's the secondary number for Cellact. We are here being moved to the checkout. Here, the service provider decided to use Stripe for the checkout for the payment provider. After a successful payment is being done, we are being redirected back to the store. The service provider validates everything, and then is generating a QR code for the installation or a deep link inside an email that can be later clicked on. This behind the scene, what it is doing, it's using the Arnacon SDK that is directly making a request to this decentralized cloud in order to write the user's identity inside. This payment and the installation inside the app that is now being done is decoupled, so we don't need to pre-configure anything before. Now it's inside the app, we are scanning, and then this is just showing how an activation will look. The service provider validates whatever he needs in front of his services, and then once everything is ready, the application is now installed inside the app. So now we have a secondary number inside this Arnacon app. And now we can dial. This specifically is how Cellact, the Secnum, decided to have their own dialer looks like. But we can have multiple applications that can be also installed in the app besides this secondary num with different service provider. Not only Cellact, it can be anybody that wants to have their own app installed. Another example is the Light PBX. It's a lightweight PBX that can be configured and run for small businesses in under 5 minutes for call transferring, redirect call, voicemail, IVR routing, or multi-ring for small businesses to interact. Different services created their own application with a custom. We can see, for example, on the left side, we have an eSIM company that deployed their own white label application with their own look and feel on top of the Arnacon runtime and installed calling model into it. On the right side, imagine Kamailio World launching their own app, their own event app, or a place where the community can interact. We can get real-time notification if a room is changed, and we can know where the drinks of tonight are going to be. This changes everything because we no longer need to maintain a SIP client. We don't need to maintain or build telecom apps from scratch. We can rely on simple plug-and-play integration and build from there. Integration costs drop significantly, and time to market become dramatically faster. Companies can experiment with new services with minimal risk, because until now, if you wanted to deploy their own app of a secondary number or a new product stream, it would require you months and a lot of money and a lot of people. And with this new model, it can be done in less than a week or even less for some other applications. We're enabling value-added services and direct-to-user telecom services. And we cut the middleman on the way. So you sell directly to your end user and install it in the app. The bigger picture is we're not building apps. We're enabling a place where apps can run easily. Here you can see a picture from the Arnacon app that installed a Light PBX for my ice cream shop, an eSIM for global telephony to when I flew to Bali, and a secondary NAM in Israel so I can call inside. And we have some other products that we installed as well. So every service provider can have his own app still installed on top of the Arnacon runtime and can still be managed and adding new products when they're launched. So users gain capabilities instantly when new apps come. Traditionally, Kamailio used as a communication engine. This is where we are turning it into a platform for services, for telecom services. Then instead of building new features into the infrastructure, we build on top of it, and Kamailio can run them. Thank you.
Thank you, Jonathan. And yeah, looks something that would make it easier. My concerns are always about adoption of these things in telecom. It's not easy, but you are here. And then Andreas.
I want to understand how the revocation work, because like in the Kamailio world, right, like earlier, like if a user reports a compromise, you just delete the user identity from the DB, right? But how does that work here in the decentralized?
That's good.
Authentication right now is being done cryptographically. So every product, every identity has a cryptographic wallet, a key pair that is used by some other like cryptographic curve. It's a Cellact curve or Edward curve. That's like a typical Ethereum curve or Bitcoin. And then this user that he owns this key pair, this identity, he can prove that he is the owner of that key pair for a fact. And if later there's like misconduct or he misbehaves, then it's no longer the Kamailio, the one that enforces this. It's the other client, the end user in the end. He can decide that he blocks communication or traffic from that people. We're making the Kamailio more as a communication traffic controller rather than deciding who enters their own house.
Thank you for the presentation. I have two questions actually. The first one is from an end user perspective. So you were saying you can deploy apps in your ecosystem. So in the end, you still need a native app on your phone to receive push notifications, right?
Yes.
Is this the Anacon app where I then can deploy my own app into it, kind of, right? Or how does that work? Or does every customer, every brand gets its own native app? That's number one. And number two is, what's the advantage of having this kind of authentication in the blockchain versus you managing it on your own central databases?
Okay, that's a good question. The first one is, you said about if you need your own app, right, to run, then you can, if you have your own application, you can just plug and play with the component I saw with the Oasis Sapphire that access this decentralized cloud that can hold your private credentials. So if you have your own APNS, your FCM tokens, everything, you come and you uploaded it there as a new service provider, and then you can, the Kamailio that is already configured to use this much bigger picture protocol can use it. We just developed the Anacon app just to have life easier for other developers that want to directly plug in new services and deploy it. But there's also an SDK that we developed, and you can plug it into your application directly and use it. It's still, all of this is, we are experimenting. We are doing a lot of proof of concept team, and we are doing some now alpha developments with some other small companies, and we see how it's going with, like what we showed before, the eSIM company. We're doing a pilot with them and showing how we can enable local telephony inside the app, because they decided they don't want to develop and maintain their own app. So they took the Anacon as a whole, and then they installed running the calling model into it, and you can still look at your eSIM data. That is like quite of the most ideal ways, but there are so many others that can be done.
Okay, for more details on this one, quickly the second question with the central database, because then soon we'll have the data break and then you can discuss more. So the second question was...
What was the second question again, sorry?
The advantage of storing authentication data in the blockchain versus your own.
Yeah, that becomes just decentralized in like the bigger picture. So none of people need to have their own database that they need to maintain, their own API that needs to maintain. And when scale becomes an issue, when you have a lot of users, an API and request, there's a lot of failure point, and you rely on a Google or AWS. We did all of these things, and we are dealing with operations all of the time of the installation didn't work, this is not functioning, the SBC, everything, all of this blocked. When we are moving into a decentralized cloud, we no longer need to maintain it. So operational just becomes almost zero. And if a Kamailio doesn't always
okay, this will have to, operation zero is something that I'm always done. That might be the case. Let's discuss it the breaks or so, because yeah, we're a bit late. We started late, so no pressure on Sandro to finish in 5 minutes.